On December 8th, under the mounting pressure of the data, NASA was forced to make the decision to shoot down the Comet 3I Atlas. 13 consecutive anomalies were recorded with a probability of occurring by chance almost equal to 0, causing a portion of the scientific community to begin seeing Atlas as a sophisticated Trojan horse, wearing the outer shell of a natural comet, but operating its trajectory and navigation system based on the very universal laws of physics, from spiral jets to the gravity assist path around Jupiter. In parallel, the continuous data stream from China shows that Atlas seems to be choosing its timing, switching its activity on and off, according to thresholds of solar radiation, and in particular entering a strong transition phase precisely when major observatories in the West fall into a 36-hour blind spot. All of this forces humanity to ask itself, have we merely witnessed an ancient rock drifting past, or are we standing before a presence quietly responding from the void between the stars? And if so, what is really happening with 3I Atlas? Is the decision to shoot down this celestial body the right choice, or the starting point of an even larger question? We will continue our journey to explore the latest data right after this. First, let's look back at the 13 anomalies that scientists have discovered from 3I Atlas. On the screens, Atlas moves across simulated star fields on a graceful hyperbolic path, entering the solar system from far beyond the known neighbourhoods of local space. The orbital solution is clear enough at first glance, showing 3I Atlas arriving on a trajectory that will skim inside the orbit of Mars and then sweep outward toward Jupiter. Engineers replay the models again and again, watching Atlas thread a corridor of space that looks narrow enough to have been chosen, not stumbled into. More data arrives, and the orbit of 3 Atlas begins to fray at the edges. Tiny mismatches appear between independent calculations, small deviations in predicted positions that should cancel out but quietly accumulate. Each new observation nudges Atlas a little off the clean curve that gravity alone would dictate, as if some additional hand rests on the trajectory. The changes are subtle, well within formal error bars, yet the pattern keeps returning whenever scientists update the long arc of Atlas across the sky. Then another layer of strangeness appears, not in the path of 3 Atlas, but in the radio noise surrounding the visitor. Buried in the background, receivers pick up a narrow signal that seems to rise and fall in step with the motion of Atlas. The frequency band is thin, unusually clean, and the timing of the pulses repeats with a steadiness that bothers people who live inside equations. Atlas is supposed to be a frozen remnant of distant chemistry, yet the signal tracks the object like a faint electronic heartbeat, following a wandering star. Physicists line up possible explanations, trying to pin 3 Atlas back inside the comfort of known mechanisms. Some point to outgassing jets to the way sublimating material can push a nucleus and carve small forces into an orbit. Others suggest instrument bias interference from terrestrial systems, anything that might explain why the numbers around Atlas keep slipping away from the simplest models. Each hypothesis can explain one corner of the behaviour, but the combined picture of 3I Atlas still feels like a puzzle, assembled from pieces of different sets. In the room, the mood shifts from routine curiosity to a softer, heavier silence centred on Atlas. The countdown to closest approach ticks forward, and every new data batch seems to whisper that 3 Atlas is not just passing through, but interacting with the measurements themselves. Somewhere between the drifting orbit and the repeating signal, a question settles over the charts, asking whether Atlas is merely obeying physics or answering a kind of unintentional conversation. That quiet question becomes the bridge to the next dilemma when scientists must decide whether the behaviour of 3I Atlas is random noise or the first hint of design. Patterns are supposed to blur when enough data arrives, but with 3I Atlas the opposite begins to happen. The more the models refine, the sharper the traces of intention appear around Atlas, as if randomness was slowly retreating instead of growing stronger. Analysts start by counting. Brightness variations linked to 3 Atlas repeat on timescales that anchor themselves around fixed intervals, coming back again and again with a precision that belongs in an engineering diagram rather than a comet log. The narrowband signal associated with Atlas holds a frequency that wanders slightly with distance, yet snaps back into the same tight window whenever the object crosses key points in its orbit. Statisticians overlay the light curve, the polarization data, and the radio traces, and find that the peaks and troughs of Atlas align more neatly than independent natural processes normally allow. Each dataset arrives from a different instrument, processed by different teams, but the fingerprints around 3 Atlas keep rhyming. Individually, every feature of Atlas can be dressed in the language of chance. A sunward jet can be framed as an unusual geometry in the terrain. A changing nickel-to-iron ratio can be framed as layered ice and rock. A rhythmic pulse can be framed as rotation-modulating exposed vents. Taken together, though, the dossier of 3I Atlas begins to look less like a catalogue of isolated quirks and more like a system running through states. This is where the word intent quietly slips into internal memos about Atlas not as a conclusion, but as a placeholder for something that repeats moves with unnerving regularity. Researchers calculate the odds that 3I Atlas could thread its way toward Jupiter's gravitational corridor, while also presenting synchronized chemical and radiative anomalies. Even under generous assumptions, the compounded probability drifts into numbers that feel more like phone numbers than natural likelihoods. The math does not prove that Atlas is engineered, but the math stops protecting anyone who wants to dismiss the question out of hand. In observatories and data centers, the mood around 3 Atlas turns reflective, almost hushed. No one wants to be the first to claim that a wandering body shows evidence of purpose, yet many quietly remember past cases where anomalies were ignored until new physics forced a rewrite of textbooks. Colleagues who have spent careers modelling chaos now find themselves tracing the calm, repeating rhythms of Atlas and wondering whether the universe is playing a familiar song in a new key. A few speak of 3 Atlas, as if the object were following instructions even while they remind themselves to use more careful language in public. Out of this tension, a bridge begins to form between data and decision. If the behaviour of 3 Atlas is genuinely indistinguishable from a system pursuing a defined path, then the stakes no longer live only in equations and charts. The same patterns that suggest possible intention also reshape risk assessments, shifting Atlas from an unusual comet into a potential actor on the cosmic stage. That quiet shift prepares the ground for the next step when leaders must decide whether to treat 3 Atlas as a cold fragment of distant rock, or as a visiting presence that may respond to whatever humanity chooses to do next. The emergency summit begins with lights dimmed and screens alive with orbital maps of 3I Atlas. Delegates from NASA, ESA, Roscosmos, JAXA, and half a dozen national observatories fill the room. The air dense with the fatigue of scientists who have stopped pretending this is a routine event. 3 Atlas has crossed every predictive boundary, its path unstable, its internal composition metallic, its emission signature structured like a language no one recognizes. The meeting is not about discovery anymore, it is about liability, risk and survival. As new telemetry scrolls across the main display, projections show a narrow corridor of uncertainty that could brush the orbit of Mars and within margins of error intersect the sphere of Earth's gravitational influence. Engineers insist the probability is still microscopic, yet each recalibration of Atlas's trajectory moves the impact ellipse closer, never farther. The arguments shift from curiosity to defense. One faction pleads to preserve Atlas for study, calling it the most valuable cosmic messenger since the dawn of astronomy. Another argues that the presence of a repeating signal embedded in the nucleus changes the moral calculus. If 3 Atlas is artificial or worse capable of response, then waiting could expose humanity to an event we are unequipped to interpret or contain. Through the night, advisors simulate interception models. Deflection scenarios demand energy levels rivaling small nuclear exchanges. Communication attempts risk revealing frequencies and defense protocols to an unknown intelligence. The final contingency, Operation Aegis, emerges from an old Cold War doctrine, a preemptive detonation designed to fragment any inbound body before atmospheric entry. No one wants to speak the word weapon, yet the document uses it again and again beside the name of 3I Atlas. At dawn, a quiet order arrives from higher command. Authorization to initiate Aegis is granted pending confirmation of anomalous behavior. Moments later, instruments monitoring 3I Atlas record a subtle shift in the narrowband signal, not stronger, not louder, but different in pattern. The pulse that had remained steady for weeks suddenly mirrors the cadence of the ground-based radar sweeping across it, like an echo that has learned timing. Observers freeze, uncertain whether they are witnessing coincidence or acknowledgement. Debate collapses into necessity. If 3I Atlas is aware, the window to act safely is closing. If it is not, the deviation could still magnify into catastrophe. Under those twin uncertainties, silence becomes agreement. The launch authorization codes for Aegis are entered and the countdown begins. Every screen now bears the same object, 3I Atlas, rotating slowly against a field of stars, a speck of ancient matter, poised between knowledge and extinction. Somewhere in the layered static of telemetry, a voice of doubt survives. Perhaps the universe never meant harm. Perhaps Atlast was only mirroring our own urgency back at us. But the clock does not stop for philosophy, and within hours the decision transforms from hypothesis to command. 3. Atlast, once the most mysterious visitor in the solar system, has been reclassified as a potential threat, and humanity prepares to erase the question before it can answer. The moment the launch codes are confirmed, the signal tied to 3I Atlas begins to shift. For weeks, Atlast has been sending a steady, almost metronomic pattern, a background pulse that engineers have grown used to seeing on their monitors. Now, the cadence of Atlas bends, speeding up in small increments that line up uncomfortably well with every new command sent to the outbound missile. Technicians replay the data in slow motion. Each time, tracking beams lock more tightly onto 3. Atlas, the narrow-band emission from the interstellar visitor, jitters, then settles into a slightly altered rhythm. The phase of the signal drifts, then snaps back into alignment at intervals that mirror software updates and course corrections aimed toward Atlast. What should be random noise around 3I Atlast instead starts to look like a feedback loop. At first, the team blames hardware. Ground stations are checked for interference, cables are swapped, firmware is rolled back. None of the changes touch the problem because the problem follows 3 Atlast rather than any earthbound system. Wherever antennas point to Atlast, the same pattern appears as if the object were weaving itself into the communication channel. Midway through the approach, a new anomaly arrives. The guidance system on the missile reports bursts of high-frequency clutter that overwhelm its sensors. Signal analysts compare the noise to the spectrum associated with 3 Atlast and find uneasily that the fingerprints match. The interference harassing the missile looks like a distorted, amplified echo of the pulse surrounding Atlast. Software teams dive into the code patching routines on the fly while telemetry scrolls past in frantic streams. For a few minutes, the corrections hold and the course toward 3 Atlast stabilizes. Then the disruption returns, this time tuned just far enough outside the patched bands to slip past the defenses. It feels to those watching as though Atlast has learned from the last attempt to quiet the signal. No one says that out loud, yet each new burst from 3 Atlast arrives moments after humans act not before, and the timing settles into the room like a weight. Radar pings aimed at Atlast provoke subtle but measurable changes in the structure of the emission. When the tracking beam changes frequency, the returning pattern from 3 Atlas changes shape like a reflection that refuses to stay passive. In the final minutes before interception, the pulse compresses into a sharp rising sequence. The waveform around 3 Atlas stacks into repeating clusters, each more ordered than the last, as if some internal system were ramping up. Instrumentation begins to fail in short synchronized outages whenever the peaks from Atlast hit their highest amplitudes. Screens freeze, reboot, and come back filled with partial gaps precisely where the strongest signatures of 3 Atlast should be. The hypothesis that once sounded dramatic now becomes hard to avoid. 3 Atlast is no longer just an object being observed. Atlast appears to be engaged in a kind of exchange, altering its emission in response to every probe and every threat. In that realization, fear and wonder mix in equal parts because a responsive Atlas means that the detonation ahead will not be happening in silence. As the warhead nears its target, the rising ordered signal from 3 Atlas feels less like background noise and more like a last compressed sequence of actions carrying unanswered questions straight into the moment of impact. The detonation arrives first as light a harsh expanding bloom on mission control screens, where 3 Atlas had been a point. For a moment the viewing windows show nothing but a sphere of brightness, a silent storm radiating outward from the place where Atlas once moved. Sensors recover faster than human attention. Particle counters spike energy curves, rise and fall, and fragment trajectories begin sketching arcs away from the vanished core of 3I Atlas. Telemetry feeds stack in layers, showing Atlas reduced to a cloud of shards and vapor, a man-made sunrise unfolding in deep space. Data teams lean in as the first spectrographic results arrive. The expectation is simple: a fading trace, a dying glow, and then quiet. Instead, detectors pick up a pattern that makes people straighten in their chairs. The signal that had clung to 3I Atlas does not disappear with the explosion. The signal spreads. Across multiple channels, the narrowband emission once tied to a single locus begins to smear through the debris field. Echoes appear where only cold dust should exist, faint copies of the original cadence repeating from different fragments of Atlas. Each pulse is weaker, but together they form a lattice in frequency space like a broken mirror, still catching light from the same source. Next come the isotopes. Preliminary analysis flags ratios that fail to line up with known decay chains, as if the interior of 3I Atlas had been assembled under conditions no lab on Earth has ever recreated. Dust from Atlas behaves strangely in electromagnetic fields, clumping and stretching in ways that resemble charged plasma, despite the relative calm of the surrounding environment. Instruments log the behavior faithfully, while operators watch with the uneasy sense that Atlas is continuing to act long after the physical body has been erased. Before dawn, a different kind of signal arrives. Classification orders roll through intranet channels, carrying language that is precise, final, and cold. All raw measurements tied to Operation Aegis move behind new access controls. Public statements about 3 Atlas are condensed into a short narrative about a dangerous interstellar comet neutralized for planetary safety. The tangled legacy of Atlas, the responsive signal, the anomalous isotopes, the structured echoes in the debris, is stripped from the official record. In the days that follow, telescopes confirm that no large remnant of 3I Atlas remains. Trajectories show only a diffuse stream of particles joining the solar wind, a harmless mist drifting outward from the sun. Headlines around the world call the mission a triumph of coordination and technology, a proof that humanity can stand between danger and home. Inside offices and darkened labs, the mood is quieter. Researchers who stared at the strange pulse of 3 Atlas remember one last detail, now sealed in encrypted archives. In the milliseconds after the detonation, the signal around Atlas briefly organized into a new sequence repeating a short pattern exactly 3 times before fading. No one can say whether that final structure from 3 Atlas was a malfunction of instruments, a meaningless fluctuation, or a last deliberate act. That unresolved question hangs over every locked file, and it pushes the investigation forward from the destroyed remains of Atlas into the larger catalogue of anomalies that defined the visitor from the very beginning. 3 Atlas is described as older than the Sun, a fragment from an earlier chapter of the galaxy. Age estimates place Atlas near 7 billion years, drifting through interstellar darkness, long before the solar system condensed from dust. For most of that time, 3 Atlas would have been cold inert and almost perfectly silent. The change begins when Atlas swings in toward the inner system and passes behind the Sun. During perihelion, thermal models predict a predictable rise and fall in surface heating, the kind that gently wakes frozen ices on a simple comet. Instead, 3I Atlas emerges from solar glare, displaying a sudden bloom of activity, as though a threshold has been crossed rather than a smooth curve followed. Observations show jets erupting from specific regions on Atlas, not scattered randomly across the surface. Cryovolcanic plumes trace arcs that repeat over successive rotations of 3I Atlas, marking stable vents rather than chaotic fractures. Spectral lines reveal fresh material being exposed in a pattern that suggests controlled release, not a one-time shattering. To some, this is only advanced geology. To others, the timing of the awakening of Atlas feels uncomfortably precise. The main surge in activity does not peak at closest solar distance, but after, as though 3 Atlas responds not just to heat, but to a sequence of environmental cues. In simulation, lab scientists replay the rising jets and shifting coma of Atlas as if watching a slow, enormous machine powering up. No one can prove that 3 Atlas contains mechanisms, yet the layered response temperature rise, outgassing structured jets, resembles a system moving through stages. The metaphor of waking up attaches itself to Atlas because the alternative language of randomness no longer feels sufficient. This does not force the conclusion that 3 Atlas thinks or intends. The behavior of Atlas may still be the complex outcome of unfamiliar physics acting on ancient ice and rock. Yet the sequence of changes suggests that Atlas is not merely surviving its passage by the Sun, but entering a new operational mode. From that possibility, the investigation widens, linking the apparent awakening of 3 Atlas to the deeper catalogue of anomalies, and to the question of how exactly humanity should watch the visitor in the nights that follow. From the ground, 3 Atlas is both generous and demanding. The visitor is bright enough to be tracked by amateur telescopes, yet distant enough that every extra centimetre of aperture feels like a negotiation with darkness. Official advisories quietly suggest that Atlas belongs to the realm of professional instruments, implying that only mirrors of 30 centimeters or more can hope to catch the faint fuzz of the interstellar coma. Observers who try anyway discover a more nuanced story. Under very dark skies with careful alignment and patient eyes, 3 at last reveals itself to smaller telescopes in the 20 to 25 centimeter range. The image of at last is not dramatic, a soft smudge against the constellations shifting from Virgo toward the pre-dawn sectors as days pass, but the presence of the visitor is real. To see 3 at last clearly, an observer must learn to look past the noise in the eyepiece, letting the mind stack successive glimpses the way a CCD stacks frames. Astronomers plot a timeline for watching at last that reads, almost like an invitation. On early December mornings 3 at last rises before the sun low on the horizon, threaded between bright stars that anchor its position night after night. The path of at last arcs slowly across the ecliptic, and those who track the motion by hand begin to feel that the object is less a transient blur and more a slow, deliberate stroke across the sky. The complexity lies not only in the optics, but in the data that follow each observation of 3 at last. Small differences in recorded brightness from backyard telescopes sometimes match shifts seen in large observatories. Amateur measurements of at last, when corrected and compiled, echo the same subtle changes in coma shape and tail orientation that professional teams report. The universe allows anyone with enough care to participate in the watching of 3 at last, yet the patterns hiding in that shared act of watching are far from simple. This bridge between simple instruments and complex behaviour adds another layer to the mystery. 3 at last is accessible enough to be seen by human eyes, and yet intricate enough to challenge the larger surveys. That tension prepares observers for what comes next, when the catalogue of anomalies around at last will no longer be confined to whispers in specialist circles, but organised, counted and weighed against the odds of chance. By the time the 13th anomaly is logged, someone finally writes the number in the margin and circles it. 3I. At last has already broken expectations by arriving on a trajectory so tightly aligned with the ecliptic plane that the orbit of the visitor looks custom fitted to the architecture of the solar system. The alignment is not perfect, but the small inclination of Atlas lies well within the band where planets and probes travel. To those who watch orbital mechanics for a living, 3 Atlas begins to resemble a guest who knows where the door is. The next entries in the anomaly list move from where 3 Atlas travels to what Atlas is made of. Spectra taken from the Coma show an unusually high nickel to iron ratio, a signature more at home in engineered alloys than in the average rubble of long-period comets. Laboratory comparisons cannot prove that 3 Atlas carries refined metal, yet the pattern of absorption lines refuses to sit comfortably inside the catalogue of familiar mixtures. The composition of Atlas hints at processes that either happened under extreme rare conditions or under guidance. Then observers turn their attention to the shape of light around 3 Atlas. Images reveal an anti-tail extending sunward, a stream of particles apparently flowing toward the star instead of a way driven by geometry and motion, in a way that feels counterintuitive even to seasoned comet hunters. Within the larger halo, spiral structures twist through the coma of Atlas, coiling like threads unwinding from a hidden spindle. Rotation alone can produce strange curves, but the regularity of these spirals around 3 Atlas suggests a stable rhythm rather than chaotic shedding. Faced with this growing catalogue, one astrophysicist proposes an informal scale, a way to rate how strongly data around 3I Atlas lean toward a technological interpretation. On the lower end of this scale sit ordinary comets whose quirks dissolve once enough measurements arrive. Higher on the scale, live objects like Atlas, where each new observation refuses to erase the previous mystery and instead stacks another layer of improbability above it. When the 13 anomalies around 3 Atlas are treated as independent events, and their probabilities multiplied, the combined odds of chance fall to a fraction so small that it scarcely feels physical. No equation here can decree that 3 Atlas is artificial, but the math stops cooperating with anyone who insists that Atlas must be entirely natural. In control rooms and offices, screens filled with plots of 3 Atlas now carry a different emotional charge, as if the graphs themselves were part of a slow conversation. Scientists who once treated Atlas as a transient curiosity begin to speak of the visitor in the same breath as probes and beacons, if only in private. The 13th anomaly does not deliver a verdict about 3 Atlas, but it shifts the burden of proof, turning each future observation of Atlas into a test not just of theories, but of how ready humanity is to recognise intention, written in the motion of a distant stranger. When the list of anomalies around 3 at last reaches 13, probability becomes a character in the story. Analysts who have spent careers taming randomness begin to ask how often the universe is allowed to stack this many rare events on the same visitor. One team treats each unusual feature of 3 at last as a separate draw from a cosmic lottery. The near-ecliptic trajectory of Atlas carries one small probability. The metallic signature of Atlas contributes another. The anti-tail, the spiral jets, the narrowband emission synchronized with motion. Each behavior of Atlas adds an additional unlikely factor. When those probabilities are multiplied instead of considered in isolation, the combined odds slip below 1 in 10 billion. Formally, this only means that the natural explanation for 3 Atlas demands extreme conditions, rare coincidences, or both. Informally, the numbers feel like a whisper that 3. Atlas may not be a simple product of unguided processes. Graphs drawn to defend randomness around Atlas begin to resemble graphs people once used to argue for design in early engineering. Out of that discomfort, a new hypothesis emerges, one that borrows its name from an ancient story. In this view, 3 Atlas behaves less like a random comet and more like a Trojan horse, a device constructed to look harmless to distant observers. The absence of obvious technological signatures around Atlas no longer comforts everyone. For some, that absence becomes the most unsettling feature of all. If a civilization wished to send a probe through foreign systems without alarming young astronomers, a body like 3 Atlas, dusty, cold, and apparently natural would be an ideal disguise. Under the Trojan horse hypothesis, the anomalies of 3 Atlas are not flaws in the costume but seams, where the underlying structure shows through. The metallic composition becomes a frame. The stable spiral jets become exhaust patterns shaped by internal geometry. The repeating signal associated with 3 Atlas becomes diagnostic output leaking from a concealed core. Nothing in this narrative can be proven, yet the alignment between data and story grows difficult to ignore. For many researchers, framing 3 Atlas as a disguised probe feels like stepping over a line. Committees remind everyone that extraordinary claims require extraordinary evidence, and that Atlas still fits however awkwardly inside the edges of known physics. At the same time, private conversations acknowledge that if a Trojan strategy exists anywhere in the galaxy, something like 3 Atlas is exactly where such a strategy would leave fingerprints. This tension does not yield a verdict about 3 Atlas, but the tension does reshape how future measurements are planned. Searches for periodicity, for engineered symmetry, and for controlled energy release around Atlas become more focused. A sense of cautious narrative enters the planning documents, as though every new observation of 3 Atlas might confirm a careful disguise or gently dismantle the myth. From that fork in interpretation, attention turns to the most delicate structures of all the spiral jets and internal rhythms of Atlas, where any hint of universal physics or hidden machinery would have to reveal itself in the quiet grammar of motion. Spiral structures around 3 Atlas appear first as faint curling threads inside the coma, easy to overlook on early images. When resolution improves, observers realize that the jets from Atlas do not fan out chaotically. The jets wrap themselves into orderly coils, as if tracing invisible rails in space. Measured over time, the plumes from 3 Atlas repeat the same shapes with remarkable consistency. The angles between streams remain stable, and the spacing of the spirals around Atlas matches a rhythm tied to the rotation period, rather than to random cracking of surface ice. For a simple comet, one would expect fractures to open and close unpredictably, but the activity of Atlas resembles a repeating program. Physicists start from the conservative view that 3 Atlas demonstrates the universality of physical law. Any rotating body that vents material into a vacuum should, under the right conditions, produce spiral paths, and Atlas becomes a dramatic classroom example for celestial mechanics. From this angle, 3 Atlas confirms that geometry, rotation, and gravity write the same equations everywhere in the galaxy. Yet the precision of those spirals keeps drawing specialists back to 3 Atlas. The coherence of the jets around Atlas suggests a finely tuned interior structure, whether carved by geology or design. That possibility links 3 Atlas directly to the next question on the table. If the internal dynamics of Atlas are so ordered, could the same hidden structure also be guiding the long path toward a specific encounter with Jupiter's gravity, using universal physics as a carefully chosen tool rather than a random backdrop? When mission planners push their simulations beyond the encounter with Mars, a new pattern emerges around 3 Atlas. The projected path of Atlas bends toward Jupiter and grazes the edge of the planet's deep gravitational well. 3 Atlas passes through the same corridor where a well-timed flyby can twist an orbit without burning fuel. Analysts mark the point where 3i at last will skim this region and overlay it on training diagrams for interplanetary probes. The geometry around Atlas matches those diagrams with uncomfortable precision. Error bars remain, but they are not large enough to move Atlas clear of the lane engineer's favour for a gravity assist. Statisticians try to keep 3i Atlas inside the realm of natural chance. They assign probabilities to the near-ecliptic approach of Atlas to the timing to the depth of the encounter and watch the combined odds collapse. The more honestly they treat each factor, the harder it becomes to call the alignment around Atlas an accident. Quietly a new picture forms. In that picture, 3i at last is not just departing the inner system. Atlas is using Jupiter as a hinge, exchanging momentum with a planet the way a probe would. The idea does not prove intention, but once the possibility is seen, it is difficult to unsee, and it follows 3 Atlas all the way toward the outskirts of the solar system. China does not announce a discovery about 3 Atlas. China announces a conclusion about Atlas. Instead of a press conference, a quiet upload appears on national servers. Dozens of calibrated images, long strings of photometric values and precise astrometric positions are attached to the name 3 at last. Every file comes time-stamped, every frame centered on at last as the visitor slides along the inner edge of the solar system. At first glance, the data look routine. The brightness curve of 3 Atlas rises as Atlas nears the Sun. The coma of Atlas expands outward as any cloud of dust and gas should. Only when analysts stretch the timeline and overlay multiple nights do the patterns around 3i Atlas begin to sharpen. The light from 3i Atlas does not simply grow and fade. The flux from Atlas holds steady for long intervals, then climbs in sudden discrete steps, as if energy release were waiting for specific conditions. The coma of Atlas does not inflate symmetrically. Expansion favours the sunward side, forming a subtle bulge that grows in lockstep with each jump in brightness. Natural models predict smoother transitions, yet the records from China show 3 Atlas moving through a series of stages. Chinese teams compare their curves with public Western reports taken before scheduled maintenance outages. Where Western observatories left gaps, Chinese telescopes watched 3 Atlas continuously. The result is a seamless arc of behaviour, a complete loop showing Atlas dim, then poised, then rapidly more active as the viewing geometry shifts. To those who trace the lines, the impression is hard to ignore. 3 Atlas appears to be waiting for a particular window. Internally, the language in technical notes grows bolder than press statements. Some memos describe 3i Atlas as exhibiting adaptive outgassing, a cautious phrase for behaviour that changes in response to circumstance. Others speak more quietly of conditional activation, an idea suggesting that Atlas holds back until observers are least prepared. No one writes the word will beside the name 3 Atlas, but the question of will hangs unspoken above every chart. The emotional weight of the verdict settles in slowly. If the continuous record from China is correct, then 3 Atlas may not only pass through the solar system. Atlas may be timing actions within the solar system, choosing moments in a way that looks uncomfortably close to intention. From that realization, attention shifts to the missing pieces in Western coverage, and to the 36 hours when major observatories turned away, and 3 Atlas moved through the most revealing phase of the entire encounter. The blackout around 3 Atlas begins as a scheduling artifact on a shared calendar. Major Western observatories block off a 36-hour window for maintenance upgrades and instrument realignment, just as Atlas approaches the most revealing part of its path. Gyroscopes are recalibrated, mirrors on key telescopes are cleaned, detectors are swapped, and priorities shift to other missions while 3i Atlas moves behind the sun's glare. On paper, each decision is defensible. Every facility watching 3i Atlas carries its own backlog of technical work. The maintenance blocks are staggered to minimise disruption, yet when analysts later overlay the planned downtimes, they find a narrow span where multiple eyes close at once, leaving Atlas unobserved. During that overlap, 3i Atlas crosses the exact region where comets tend to show their internal structure most clearly, peak outgassing maximum stress on the nucleus, higher sensitivity to hidden fractures. Data from before and after the blackout show 3 Atlas following a smooth arc in position, but a jagged curve in brightness and coma shape. The missing hours contain the moment when Atlas's activity appears to pivot from a modest steady regime into a more aggressive directional mode documented by Chinese observatories. Western teams later fill the gap with interpolations sketching a plausible behaviour for 3i Atlas between the last pre-maintenance frame and the first post-maintenance frame. The reconstructed sequence looks tidy, but the underlying truth remains no one on that side of the world actually saw what Atlas did when the instruments were offline. For some, the alignment of schedules around 3I Atlas is an unfortunate coincidence amplified by hindsight. For others, the odds that multiple premier facilities would all pause during the same critical window for Atlas feel too small to ignore. The suspicion is not that any single agency conspired to look away from 3I Atlas, but that systemic pressures, budget cycles, and shared planning tools created a blind spot where an interstellar visitor could change without immediate witness. Emotion enters quietly into this analysis. Researchers who devoted nights to tracing 3I Atlas now confront the fact that the most important transformation of Atlas may have unfolded in darkness, not in space, but in human infrastructure. The 36 hours become a symbol of how fragile global awareness can be when it depends on machines that must sleep. From that recognition, attention shifts to the continuous record that does exist, the uninterrupted watch on 3 Atlas maintained from another hemisphere, and to what that complementary vantage point reveals about the behaviour that slipped through the Western Gap. While Western observatories cycle through their maintenance routines, Chinese telescopes keep their gaze fixed on 3I Atlas. Night after night, Atlas remains on their sensors, a pale visitor traced without interruption as it rounds the inner reaches of the solar system. The resulting archive is not a handful of snapshots, but a continuous film of 3I Atlas unfolding in time. When analysts play that film frame by frame, the behaviour of 3I Atlas refuses to match the simple story of ice evaporating in sunlight. The brightness of Atlas does not climb along a smooth, lazy curve. Instead, 3 Atlas holds steady, then jumps, then holds again, producing a staircase of light where a natural comet would most often draw a slope. Each jump in luminosity from Atlas coincides with subtle changes in the coma, as if new layers of material were being exposed in discrete phases rather than melting away. The shape of the surrounding envelope deepens the puzzle. In the Chinese data, the coma of 3 Atlas thickens preferentially toward the sun, forming a sunward bulge instead of a uniform halo. As the hours pass, the tail of Atlas stretches and straightens, lengthening at a rate out of proportion to the modest increase in solar distance. Dust models predict more gradual shifts, but 3 Atlas behaves as though some internal gate opens and closes, modulating how Atlas releases stored energy into space. Overlaying solar flux records adds another layer. Whenever bursts of radiation sweep past 3, Atlas, the narrowband signal tied to Atlas, flickers, then reasserts itself with a slightly altered pattern. The timing is not instantaneous, but delayed like a system that takes a moment to process input before responding. For some analysts, 3I Atlas begins to look less like a passive object and more like a device with a trigger it's on state synchronized with thresholds in the surrounding environment. The phrase activation response appears in early drafts of internal reports, a cautious way of describing how 3I Atlas seems to wake more fully when conditions align. Graphs of Atlas once read as records of simple heating now resemble logs of a system stepping through modes. Around conference tables, the emotional tone shifts from curiosity to a quieter, heavier awareness that 3 Atlas might be interacting with sunlight and observation in a way that borders on deliberate. From that realization, the next step becomes inevitable, merging every stream of data, Eastern and Western, into a single timeline to see whether the entire dance of Atlas points toward a sustained, coherent intent. When the last missing pieces are added, the story of 3 Atlas collapses into a single continuous timeline. Data from Western observatories and Chinese surveys interlock around Atlas like teeth on a gear, filling the blackout with measurements that were never meant to meet. Plotted on one axis, the position of 3 Atlas traces a clean hyperbolic escape, an object arriving from outside the solar system and destined to leave again. On another axis, the brightness of Atlas forms that strange staircase of light with plateaus and sudden rises that ignore the smooth heating curve of a normal comet. Layered over both the narrowband signal, bound to 3 Atlas pulses with a rhythm that shifts in response to solar flux, and radar sweeps as though Atlas were listening as well as shining. The unified timeline reveals that the key transitions of 3 Atlas happen not randomly, but at junctions where observation and environment intersect. Brightness jumps from Atlas often follow bursts of solar radiation, but not immediately. The changes in Atlas arrive with a delay that matches internal processing more than blind reaction. Adjustments to tracking strategies on Earth precede subtle morphing of the emission pattern around 3 Atlas, suggesting that Atlas is entangled with the act of being watched. When orbital analysts recalculate the path of 3 at last using the complete dataset, the uncertainty shrinks dramatically. The course of Atlas through the inner system and toward Jupiter's gravitational corridor tightens into a line that looks less like a lucky guess of nature and more like a trajectory following a script. The same models that guide probes now describe the future motion of 3 Atlas, with unnerving accuracy turning at last into something that behaves like both a comet and a mission. From these converging threads, a new phrase begins to circulate: interstellar intent. It does not claim that 3 Atlas thinks only that the behavior of Atlas resembles a system pursuing a consistent objective across changing conditions. The term is controversial, but without it, the patterns around 3 Atlas have no concise name, and unnamed patterns are too easy to dismiss. Emotion enters quietly at the end of the analysis. Scientists who align the final plots feel as though 3 Atlas has been writing a long, slow message across the solar system, using gravity, light, and silence as its alphabet.